Hello, this is Mr. Lonergan. I'm going to be talking with you about SAT practice packet number 8. We're going to look at two questions today, number 7 and number 10. Stay with me. They're actually quite connected. The first one is number 7. It says that the figure below is formed by a triangle overlapping a rectangle. What does A plus B equal? There's A, there's B, and here's our choices. There's actually a couple different ways to do this. I'll show you both. The first one is to remember the rules of transversals. One in particular that says that if you have two lines that are parallel and a transversal that goes across the middle, then you have all kinds of sets of congruent lines. The one that's one of my favorite is alternate interior angles, and those are the two angles that are on the inside of this blue Z shape. So you see this space right here where it's angle B is the same size as that angle right there, B. Once I put A and B together and say A plus B has to be a straight angle, it's easy to see that the best choice for this would be choice D. There's another way to get there though as well, and it goes with looking at just the shape of what's left. We've got A and B here, and because this was originally a rectangle, we know that this is 90 and this is 90. The shape we have here that I'm highlighting in pink has 4 sides. And as I think about a four-sided figure, I'm going to remember some rules and some patterns that were at the front of the problem set. It says polygons. If a figure has more than 3 sides, just add 180 degrees for each extra side it has after 3. For example, a 4-sided figure has 360 degrees, a 5-sided figure has 540 degrees, etc. What does that really mean? Well, one way I think about it is that if it's got 3 sides, it's 180 degrees, and every time this number goes up by 1 to 4 sides or 5 sides, this number goes up by 180 to 360 degrees, 540 degrees. I forget that rule sometime, but I remember that if I look at a 4-sided figure like this, I can draw a diagonal line and divide it into 2 triangles that are each 180 degrees. And only thing I need to remember is that one right there. A triangle has 180 degrees. So if this pink figure has 180 plus 180, 360 degrees total, and I know that 2 of them are 90 degrees, that means what's left for A and B put together is 180 degrees, just like we already knew. Now, when we look at problem number 10, here's my poor example of it, we can do the same process. Problem number 10 says, what is the total number of degrees of the interior angles of this figure? One way to look at this is to just count 1, 2, 3, 4, 5 sides of this figure. 5 sides we already talked about earlier on. 540 degrees. Don't believe me? Well, then let's take it and see if we could cut it into how many triangles we could cut it into. Now, I'm only going to go corner to corner, and in this case it happens to be kind of right angles that will allow me to cut this into 3 triangles, each of which has 180 degrees. 180 times 3 gives me that answer I already knew that I had, 540 degrees. So, if I'm asked about the number of degrees in a shape, I'm going to remember my pattern, or I'm going to remember this trick of dividing it into triangles and then counting how many triangles there are and remembering that each triangle always has 180 degrees. Ciao.